Okay, hello friends. Today we will be doing the AMC 10B 2023 problem 11. So let's dive right in. Suzanne went to the bank and withdrew 800. 800 what? Bananas? No, obviously $800. Bank dollars most likely, unless she's not living in US. But we know she is because this is a US competition. So the teller gave her this amount using $20 bills, $50 bills, and $100 bills, which at least one of the denomination. Now you might be like, denomination? Huh? It's just like something to throw you off with all these fancy words. All that really means is that there's at least one $20 bill, at least one $50 bill, and at least one $100 bill. Moving on. The question is asking us, how many different collections of bills could Suzanne have received? Now, alright, this is one of those AMC 10 problems that looks scary at first, but once you see the structure, it actually becomes super manageable. We let A, B, and C represent the number of $20 bills, $50 bills, and $100 bills. The total is $800, so we write 20A plus 50B plus 100C equals 800. Now I immediately simplify everything and by dividing by 10, which gives us 2A plus 5B plus 2A plus 5B plus 10C equals 80. The key idea in AMC problems like this is that instead of trying to solve everything at once, you break it down into cases based on the variable with the biggest impact, which here is C. Therefore, I isolate C by rewriting it as 2A plus 5B equals 80 minus 10C. You might be like, why does that work? But again, as I said, you break it into cases. Well, really, you break it into just different sides, and this will make it easier, trust me, because the most denomination is 100 and 80 and 10 versus 2 and 5. So we want to take note of that here. And next, so I pause here for a second because this is actually a really common AMC pattern. When you see multiple denominations or weighted contributions, AMC almost always expects you to reduce it to a smaller equation and then count cases instead of solving directly. And that's something you see in general. Problems aren't about heavy computation, so you have to turn a big, messy equation into a smaller pattern and count symmetrically. Now, back to the problem. Since we need at least one bill, C has to start at 1. Also, C can't be too large because $100 bills alone can't exceed 100. So C goes up to 1 to 7. And why can it go just $100 bills alone? Because as said here, one of the denomination. So we can't exceed that. And therefore, C goes from 1 to 7. So continuing, now I just plug in values of C one at a time. Each time I compute the right side, which is 80 minus 10C, and then I count how many positive integers pairs A and B satisfy 2A plus 5B equals that number. So the solutions for C equals to 1, I get 70 on the right side, and that gives 5 solutions. For C equals to 2, I get 64 solutions. C equals to 3, I get 54 solutions. For C equals to 4, I get 40, which gives 3 solutions. C equals to 5, I get 33 solutions. For C equals to 6, I get 20, which gives 1 solution. And for C equals to 7, I get 10, giving 1 solution. Now I just add everything together. So, practically just the sum of all this. And that gives 5 plus 4 plus 4 plus 3 plus 3 plus 1 plus 1 equals 21. Now we look for that here. Which one? B. So therefore, our answer is B. So I hope that makes sense to you. And stepping back, this is really an AMC problem. You don't brute force it, because honestly, if we brute forced it, we would have just been stuck. And another thing, dividing the equation really helps. And I know it's just like a small thing, so it might seem like, is that really necessary? But yes, it is. Because if we didn't divide here, it would have been a much harder problem. So that's another thing. That's basically the difference between getting stuck and moving fast here. So this is her HD AMC math, and we're done. I hope you learned from this video.